Okay, hey guys, welcome to the OneClass channel. My name is Sydney and I'm currently a third year engineering student. Today we're going to be going over some commonly asked math questions at both the high school and university level. If you need some additional homework help or tutoring, please check out the links in the description below. Okay, let's get started. Okay, for the first question, we're asked how to find the prime factorization of a number. So first, let's talk about what a prime factor is, or even just what a factor is. So a factor is, or factors of a number, are the numbers that when multiplied together they give the original number. So you can see an example here where it gives that 2 times 3 is 6, and the number 6 has the factors 2 and 3. Okay? That's what it's showing here in the answers on the left. We also have another example that 12 has the factors of 1, 2, 3, 4, 6, and 12. And we can show that 1 times 12 equals 12. So that's why 1 and 12 are factors. 2 times 6 is equal to 12. That's why 2 and 6 are factors. And 3 times 4 is equal to 12, and that's why 4 and 3 are factors of 12. Okay? So a prime factor then is a factor that can only be divisible by its self and 1. Okay? Or a prime number, sorry, and the prime factors then, I'll show you here, are when you take a number, such as with 12, a prime factor of 12 would be 1, 2, and 3, because those are only divisible by themselves and 1. 4 can be divided further into 2, and 2, I guess 2 times 2, so just 2. And 6 can be divided further, okay, into other factors. But 1, 2, and 3 are no longer divisible by anything but, or you cannot get them without multiplying themselves by 1. So 2 times 2 by 1 is 2, and 3 by 1 is 3, and those are the only factors. In the example here, it shows that a good way to find what a prime factor is by breaking it down in this tree format, okay? So yeah, I'll just write this out. So the way that we can find what the prime factors of 24 are is by breaking it down into its factors. So 24, you can get 24 by multiplying 2 times 12, and 2 here is a prime factor because you can't divide it into anything else but 2 times 1. So that's a prime factor, but 12 can still be divided further. So you have 6 times 2, where 2, what we already said, is also a prime factor. But 6 can be divided down further to 3 times 2, and that's the final form because 3 isn't divisible by anything but 1 and itself, and 2 is the same again. And that shows you that 12 by its prime factors is 2 times 2 times 2 times 3. So these can all be called prime factors. And this is prime factorization. Okay? Leave a comment here saying good work. Correct solution. And we can go on to the next question. Okay, so question number 2. So this question asks, what is the derivative of ln x? So we have y equals 2 ln x, and we want to find the derivative of this. So what we want to do is change this into a different form so that it's easier to work with. Okay, so we know that using our ln rules, that if you raise both sides to an exponential, ln x, like this, we know that the the exponential, and the ln essentially cancel each other out so that it is equal to x. Okay, so now that we have this form, it's the same equation, different form, we can take the derivative a little bit easier because we know what the derivative of an exponential is. All right, I'll just write the rule here. We know that the derivative of an exponential to the exponent y, actually, in this case, I'm going to write to the exponent x because I'm taking the derivative with respect to x, is just itself. Okay, so that can be easily translated here. If we take the derivative then of this equation that we just came up with, of e to the y, and also take the derivative of the other side as well, of course. This side becomes 1 because it's just dx over dx. And this side, we get whatever the derivative of the exponential is, which we saw in the in green here from the rule, that it is just itself. But because we're taking the derivative of a function with y, we need to add in the second factor, that is the derivative of y, just acknowledging that we're taking the derivative with respect to x and not y, and that is equal to 1. So now we just need to isolate for dy by dx because that's what we're looking for. Here we can say dy by dx. We want to know what this is, right? So this is asking what is dy by dx. So rearrange for this term, and all we have to do then, well, before that actually, I'm going to sub back in x is equal to e to the y. Okay, so up here, remember we rearranged our original equation of y equals to ln x. We rearranged it so that it was in an easier form, right? So we can actually just sub that back in for x, and then we'll get, subbing that into here, we'll get x times dy by dx is equal to 1, or dy by dx is equal to 1 over x. And this effectively is the derivative of ln x. And you can confirm that because, well, up here we wrote dy by dx is equal to the derivative of ln x, and then we have it equal to 1 over x, but I was saying you can confirm that just because it's one of the rules when you're looking up the derivative for the exponential function, you'll probably also find the rule for this as well, which is equal to 1 over x. Okay. Let's say correct. Good work. And we can move on to the next question. Okay, so our next question is asking us to explain, I guess, Penmasks rule in math. In school, I learned Penmasks, so I'll write it in both ways. This is question 3. So we can either have Penmasks or Penmasks. And I'll just explain what this means. So the P or B stands for parentheses. I can't even spell it. Oops. Parentheses. Or the B stands for brackets. E for exponential. D for division. M for multiplication. A for addition. And S for subtraction. So the order that the letters appear in the words tells you the order of operations. Order of operations. So that means when you come across a multiplication, or I guess I should clarify, not specifically multiplication. If you come across any type of math question, you need to know which order you perform these different operations on the equation, okay? So, yeah, the multiplication, division, and the addition and subtraction, these can be interchangeable with each other, so you can do them in whichever order they appear first. So I'm going to say that the order doesn't matter for these two. So that means if you have multiplication before division or division before multiplication, it doesn't really matter. And the same thing goes for addition and subtraction. So order doesn't matter. However, for example, if you come across an exponent, you want to do that operation before you add or subtract, let's say, okay? Let's go through just a quick example so that you can see how this can be applied, okay? So if we have this given to us, plus 12 divided by 4 times 3 minus 4 plus 10, you want to look at which part of this, I guess I'm going to call it equation, you're going to work on first, okay? So because of a rule that says Penmasks or Penmasks, we want to work on brackets first. So that means we have to work on everything that's inside the brackets before we touch, this 36 or the 10, for example. We're going to start inside the brackets. Next, going from left to right, because that's, how we normally read it, we have 20 plus 12 divided by 4. Well, we see up here that division comes before addition, right? So that means we're going to work on the 12 divided by 4 before we do the addition. So we'll go through this. 36 minus 2 times 20 plus, well, we have 12 divided by 4. So I'm going to do that first. That's 3 times 3 minus 4 plus 10. So the only thing I did here was the 12 divided by 4. Next, we see that we have multiplication. Once again, multiplication comes before addition and comes before subtraction. So we're going to do that step next. 36 minus 2 times 20 plus 3 times 3 is 9 minus 4 plus 10. Okay, so next we see, since we're still working inside the brackets, because that's top priority here, we're going to do the addition and subtraction inside the brackets. Like I said before, I keep scrolling back and forth, but addition and subtraction, the order doesn't matter, so that means that I can add 20 plus 9 and subtract 4. All at the same time. I can do 20 minus 4 plus 9. Either way, it will come out as the same. So 36 minus 2, we have 20 plus 9, that's 29, minus 4 is 25, plus 10. Okay, so now we are at this point, and we see that we have subtraction, addition, and multiplication. So according to Penmasks, we're going to do 2 times 25 first. So we have 36 minus 50 plus 10 is the 2 times 25. And because we have subtraction and addition, once again, order does not matter. So we are going to do this all in one step. And then we'll get the final answer of minus 4. Okay? So that is how you work through an equation using Penmasks or Penmasks. I'll go through the solution on this side. And using the same example, they get the same answer. So, good work. The solution is correct. All right, on to question 4. This question is asking us, what is an obtuse angle? Okay, so an angle, we know, can look something like this. Not very straight line, but I guess you get the idea. An angle is the space here that's formed at the corner when two different lines intersect. So these could be lines, rays, vectors, whatever. And it's usually denoted like this with the curved line, sometimes with a little arrow, and that's the angle in between two lines, okay? So we have 3 different main types of angles we typically look at. We have, well, I guess I can use this one as an example. We have an acute angle. So that occurs when the angle is less than 90 degrees. So if this is 90 degrees, this angle will be less than 90 degrees. We also have if 2 lines are perpendicular to each other. Instead of drawing a curved line to show the angle, we will draw a little box like this, and that signifies that this is a right angle where the angle is exactly 90 degrees. So that occurs when the 2 lines are perpendicular to each other, okay? And the third type of angle is what we call an obtuse angle, right? So if this dashed line tells you where the 90-degree mark is, this angle, the obtuse angle, happens when it is an angle greater than 90 degrees. Usually, or for it to be an obtuse angle, it has to be less than 180 degrees. This is 90, this is 180, so it also has to be less than 180 degrees to be an obtuse angle. Okay, that's it for this question. And this is just maybe a better drawing of it here. Okay. Oops. All right. Question number 5 asks to evaluate the line integral where C is the given curve, and then it gives us some parameters. So I'm just going to write it out here so it's a little bit more clear. But it's saying that the function is x of y, and this is representing the curve C. It also gives us that x is equal to t squared, y is equal to 2t, and t is within the bounds of 0 to 1, okay? And ultimately, it's asking us to evaluate the line integral. Okay. We know that the line integral, the line integral is defined like this. We have integration for the curve C, that's what that little C means, for the function by ds, that is where ds is equal to square root of dx by dt squared plus dy by dt squared dt. So dt is outside of this square root. Okay, so if we want to evaluate the line integral for this function, the given function of x times y, we need to determine what the derivative of x with respect to t is, and what the derivative of y is with respect to t, so that we can sub them all in. All right, so let's start off with x. We have x equals to t squared. So taking the derivative, we have dx by dt is equal to the derivative of t squared, and that is just 2t using the power rule. And then we also have y equals to 2t, and the derivative of that, taking the derivative of each side, we have the derivative of y, well, I guess I don't need to write that again. Derivative of y with respect to t is then just 2. That's taking the derivative of 2t on the right-hand side. Okay, so now that we have the derivatives here and here, we can sub that in to the full equation for the line integral. So I'll just rewrite it here. Integrating over the curve C, we have our function by ds. That is equal to, I'm just going to write in the given function. So our given function, subbing in for this portion here, is x times y. That's what I wrote up here, right? So that's x times y. And then for ds, remember we have to sub in our definition here of what ds is. So that's the square root of, I'm just going to keep this showing so you can see. Hopefully they're not cutting it off. We have the derivative of x, which is 2t, found up here, squared, plus the derivative of y, which we found here, to be 2 squared by dt. Okay? But we have to remember about the bounds, okay? Here it's undefined. It's just stating that it's over the curve C. But on the right-hand side, we have to define what those bounds are. Because we're taking the integral with respect to t, we need to find the bounds with respect to t as well. And in the original question here, it states that t is within the bounds of 0 to 1. So that's what we're going to be integrating by. So t equals to 1 on top and t equals to 0 on the bottom. Okay. I'm just going to also sub in x and y here so that everything that we have being integrated is with respect to t. Makes it easier for us. So, well, we don't have to write the t equals every single time. I'll just write 1 and 0. And we also have, remember, x is equal to t squared, and y is equal to 2t. I'm also going to kind of expand this portion here. So we have 4t squared plus 4 by dt. Okay, so when we expand this this part, it's just 2t cubed. Just going to rewrite this. Now that we have everything expanded or written, basically simplified, we have to start kind of rearranging it. Actually, there's one more thing that we can do to simplify this even further, is we can factor out, we can see that there's a 4 here and a 4 here. If we factor those out, we might be able to make it a little bit simpler for ourselves. So we have, I'm just writing out in a lot of steps so that you can see exactly what's going on here. Actually 1 dt. Yep, and we know for square root of 4 is just 2. So writing this again, we have 2 times 2 is 4. Okay, d squared plus 1 dt. Okay, now that we're at this step, we have to figure out how we are going to take the integral of this. So, in order to take the integral of something like this square root, the term under the square root here, we are going to do a substitution, okay? I'm going to say let u equal to t squared plus 1. So that's everything here underneath the square root. If you rearrange that, we're going to play around with that a little bit so that we're able to sub in u for t, for this t, u for t under the square root here, and then we also need to replace the dt with a du. So everything will be respect to u instead. We also have to remember to change the bounds because remember this is equal to t and this is equal to t. We have to replace those as well. I'm just going to do that one afterwards. So yeah, I wanted to say u equal to t squared plus 1. You can also rearrange that and say that t is equal to the square root of y minus 1. you have to take the derivative of this, which you'll see why later, just so it can be subbed in for dt. So take the derivative of both sides. We get du by dt is equal to 2t, because of course, remember, the derivative of 1 is just 0. So rearranging, we have du equals to 2t dt. Okay, so we have a few different components here that we can use. We have this, we have what t is equal to, and we have what du is equal to. All right. So working with this equation, going back to this, we have, remember to change the bound. So originally we have t is from 0 to 1. So that's what we're going to use this equation for. Nope, that's not true. That's what we're going to use this equation for. So to find the bounds, we are going to say that, so this is going to be u equals to something new and u equals to something else. So for the top bound, we have u equals to, and then for t, before we had 1 squared plus 1, and that is just 2. So u equals to 2. And then on the bottom bound, we have u equals to, and for t, we have 0 squared plus 1. So that just means u equals to 1 on the bottom bound. So change the bounds. Now we have to rearrange. Well, I'm going to write it, I think, under here, just so that we can see it separated a little bit. Yeah, because it's before we change it to u, we need to sort of move things around. So we have 2t squared. All I'm doing is separating this 4t cubed term. So it's a little bit easier to see what we're doing. So taking out a 2 and a t from the 4t cubed, and I'm just moving it to the back. Now that looks familiar. This, it's a little bit squishy in here, but this term is, remember, this term. So that can be subbed in for du when we get there. But first, I'm going to tackle this 2t squared. Oh, hopefully I'm not cutting that off. 2t squared term, right? So 2, and then if we're subbing in t squared for this t that we found here, we have square root of u minus 1, and square that. If we remember, we're saying this is t, so we need t squared, times underneath the bracket, instead of t, or not bracket, sorry, square root, instead of t squared plus 1, remember we said that we wanted to let u equal that. So we just have the square root of u. And for replacing the 2t times dt, we created this du term. Right? Hopefully that makes sense. So we have all new bounds for u. We substituted all the t's with u's, and now we are ready to, well, after rearranging, we'll be ready to take the integral. So the square root of, or the square of the square root will just be u minus 1. We also have square root of u by du. I'm just going to keep this in the brackets to keep it separate. Okay, and let's just distribute this into the brackets. And at the same time, I'm going to take out this 2 since it doesn't need to be integrated. So we have 2 times the integral from 1 to 2, and then distributing the square root of u into the brackets, we then get u 3 over 2, because remember, square root of u is equal to u to the exponent of 1/2. So distributing into the bracket will give you u to the power of 3 over 2 minus u to the power of 1/2 du. And now we have a simple integral to do here, okay? It's just using the reverse power rule, which I guess I'll write here so it's a little bit more clear to see. We have, reverse power rule, which states that the integral of x to the power of n by dx is equal to xn plus 1 over n plus 1 plus, well, usually a constant if the boundaries are undefined, but in this case we have defined boundaries, so we don't need to include a constant. So as I do this integral, if it's not clear to you exactly how I got everything, if you want to write it out in this format with by writing out n plus 1 as the exponent plus 1 instead of just going straight to the next step, then maybe that'll make things a little bit more clear for you. But basically, from the step up here, I'll probably run out of room. From the step up here, we can get that the integral is, put it in one big bracket, u 5 over 2, 5 over 2, and we're going to evaluate that from 1 to 2, and subtract or minus. What I'm basically doing here is taking the integral of each one separately and evaluating them separately rather than all at once, just because it seems a little bit more clear to me. And then for the next one, we have 3 over 2 divided by 3 over 2 evaluated from 2 to 1. Okay? So, yep, don't forget that the 2 is out front, and that will multiply everything within the brackets because we took that outside of the integral a little bit earlier. All right, so what I'm going to do now is evaluate and basically replace the u's with 2 and 1. So 2 times everything. We have first we replace the u with a 2. We have 2, 5 over 2 divided by 5 over 2 minus 1, 5 over 2, which we can kind of just ignore because 1 to the power of anything is still 1, divided by 5 over 2. So that's just evaluating this first term. And now we're going to evaluate the second term, so replacing u with 2. 3 over 2, 3 over 2, minus 1, and remember this is a 3 over 2, but we don't need to write it, divided by 3 over 2. Alright, there's not too much we can continue to do here, just simplifying, but we basically solved it. It's up to you if you want to leave the exponents in a fraction form, or if you want to change it back to a square root form. And I'm just going to move the 2 from the denominator because it's a fraction in a fraction. I'm just going to simplify that a little bit. So we've got 2 times square root of 2 to the 5 under a square root divided by 5 minus 2 divided by 5. That's just rearranging this fraction here and flipping the 2 up on top. minus, well, I guess I can distribute this minus as well into the bracket. So we don't need those extra brackets there. And we get minus 2, well, square root of 2 cubed divided by 3. Oh, I forgot about the 2 here. Let's just put that on top as well. Alright, minus 2 over 3. Okay, now that we're at this point, if you want, we can find a common denominator, which lowest common denominator here is just 15. And we can also, well, I'll just rewrite the top here, numerator. Minus 2 minus 2. Oh, I messed up the sign here because we distributed the minus sign, remember? That just will change to positive. 2, 3 plus 2. Oh, I forgot to change every coefficient here. So in order to change that to a 15, we need to multiply it by 3. Can't forget. Minus 6 minus, and then for this one, to change it to a 15, we need to multiply by 5. So we have 10 plus 10. Alright, now that we have this, of course you can just add these two together, but I'm just going to go straight to the final answer. If this is a calculus class, you might not be able to use a calculator, but if you are, then the final answer is 1.2876 rounded off. Alright, and that is the final answer. In this solution, they leave it as this final answer. The step right above is basically the same as what we've got here. So I'm going to say, oops, good work. Well done. Well done. And that's all we're going to do for today. If you found this helpful, please leave a like. And if you want to be notified of when we do another Q&A, please hit the subscribe button and hit the notification bell. If you want to submit any of your own questions, you can see the links in the description below or just leave a comment. And that's all for today. Thanks for watching.